Hello everyone, welcome to my YouTube channel Zenith GATE Mechanical. Continuation with the concept and question series. So this is the question based on the coplanar concurrent system on. That means all these forces are lying in the same plane and they are passing through the point, this one. So let us suppose this point is O. So what is the question? A welded connection is in equilibrium under the action of four forces. Four forces are acting. Knowing that FA value and FB value is given, so determine the magnitude of other two forces. So you have to calculate FC and FD value. FC and FD value, FA and FB are given. So if only three forces are acting, then you can use the Lami's theorem. There is no problem. But more than three forces are there, then means you have to use the generalized approach. Summation of force in X direction 0, summation of force in Y direction 0. Okay. So for that, what you will do, you will resolve all the forces in the X direction and summation of force in the Y direction. So that means you will resolve the force in Y direction as well as in the X direction. But you need the angle of this particular force with this horizontal axis, X axis. For that, they have given you this particular value. This is 3 and this is 4. So if you consider, let us suppose this is theta. What is this? This is 3. This is 4. So can I write? So the cos theta is 4 by 5 and sin theta will be 3 by 5. Okay, now what you will do, you will apply the summation of force in X direction 0 and summation of force in Y direction 0. So you can resolve this particular force FB in this direction and the perpendicular direction. Similarly, FA force in this direction and this direction. Okay, so let us suppose this is the point O. One force which is acting, this is FC, and this is FB. So what is the component here in this direction will be FB cos theta. So in this direction, nothing but FB sin theta. Now, one more force which is acting in the downward direction, this is FD. Again, you can resolve the forces FA in the X and Y direction. So I'm assuming this is the X direction and this will be the positive Y direction. So this value will be FA. So if this is theta, so alternate opposite angle, this is also theta. So FA sin theta, and here will be FA cos theta. So by using the summation of force in X direction 0, what you can write? Summation of force in X direction 0, FA cos theta, which is minus plus FB cos theta minus FC is equal to 0. So can I write FC is equal to FB minus FA cos theta? So what is the FB value? FB value is 16 and FA is 8. So this value will be 8 cos theta, which is nothing but 8 into 4 by 5, 32 by 5. That means approximately 6.4 kilonewton. So this is the FC force. Now you have to calculate the FD force also. So take the summation of force in Y direction. So F summation of force in Y direction 0 means FD, which is minus of FA sin theta plus FB sin theta. So from here you will get FD value is FB minus FA sin theta. That means 8 into sin theta, which is 3 by 5. So 24 by 5, which is nothing but 4.8 kilonewton. Okay. So you have calculated the FC force as well as FD force while resolving all the forces B and A in the X and Y direction. And you have used the two equilibrium conditions, summation of force in X direction, summation of force in Y direction. You got the result. So this is the coplanar concurrent force system. So two cables are tied together at the C point and they are loaded as shown in figure. Determine the tension A. The first part is in the cable AC as well as in the DC. Okay, that means one force is known to you and these two forces you have to calculate. Directly you can use the Lami's theorem. But what is the main important point here? These angles are not given. Okay, so what is this angle? And this angle is not given to you. First of all, you will calculate the angle by using the geometry. So let us suppose if I will draw a point C, one force is acting as a 1.98 kilonewton. So let us suppose the tension here is tension BC, and here will be the tension AC. Okay, so let us suppose this angle is alpha, and this angle I am assuming as a beta. Okay, now this total value is 3.6 and this is 2. So can I write this value will be 1.6, 1.6, 1.6 meter. And what is this value? This value is 3 meter. Similarly, this value is 4.8 meter and this value is 2 and this is 3.4. So this value is nothing but 1.4, 1.4 meter. Okay. So this is alpha I have assumed and this is beta I have assumed. So alpha value and beta value you can calculate by using the simple relation. 10 alpha is nothing but 1.4 perpendicular by base and 10 beta is nothing but 1.6 divided by 3. From here, once you will solve, you will get alpha is equal to 16.26 degree. Similarly, the beta value is 28.073 degree. Okay, so alpha and beta value now it's known to you. So now the problem is very simple. You can easily calculate the tension AC and BC by using the Lami's theorem. Okay, so what is the Lami's theorem? Tension AC divided by sine of 90 plus beta is 28.073. Similarly, tension BC divided by sine 90 plus what is the alpha? 16.26 is equal to 1.98 divided by sine of 180 minus alpha plus beta. Okay, because I have to calculate this value, so total angle is 180. So I'm just subtracting alpha and beta value. So once you will solve, then tension AC and BC value you will get 2.5 kilonewton in AC and for BC 2.72 kilonewton. Okay, so you have to calculate the tension in cable AC as well as BC. So you got this value 2.5 as well as 2.72. This question was asked in the GATE exam only. A bar of uniform cross section whose weight is 100 Newton is held horizontally by using the two massless and inextensible string. Okay, so this is basically a bar whose weight is given 100 Newton that is balanced by the two string. So if I will draw what are the different forces which is acting over this bar, here is the one force which is nothing but weight of this bar. So let us suppose this is B point, this is A and this is C. So here the tension will be T1 and here the tension will be T2. Here the tension will be T2. And this length is given as L by 2 and this is also L by 2. Okay. Now summation of force in y direction 0, if you consider, you will get T1 plus T2 is equal to 100. Okay, because T1 and T2 in the positive direction and this 100 will be in the negative direction of y-axis. Because I'm using this is the positive x-axis, this is positive y-axis. So let us suppose this is first condition. So if you apply the summation of force in the x direction 0, there is no force acting. So only one equation is left, which is nothing but summation of movement about any point. So I will consider the movement about a point is equal to 0. So which is nothing but T2 into L by 2, which is nothing but the force into perpendicular distance in the anti-clockwise direction. And this force is acting downward. It is creating a clockwise movement. So T2 into L by 2, I'm taking anti-clockwise as a positive. Okay, so this direction I'm assuming as a positive. and the clockwise is a negative. Okay, you can use your sign convention also, but you have to follow in complete equation the same sign convention. So anti-clockwise is positive, means T2 into L by 2 minus this 100 is acting downward. So 100 into L by 2, clockwise is negative. So T2 value you got as 100. If T2 is 100, what is the value of T1 from first equation? This will be 100 minus 100 is nothing but 0. Okay. So you got T2, T1 is 0 and T2 is 100 Newton. And this is the answer for this question. So which option will be the correct? The option B is correctly matching. T1 is 0 and T2 is 100 Newton. So the option B is the correct answer. Okay. Now move to the next question. This question is also a gate problem which was asked in GATE 1995. A very simple question. A spring scale indicate a tension T in the right hand cable of the pulley system as shown in figure, neglecting the mass of pulley. So you have to neglect the mass of pulley and ignoring the friction. Okay, so there is no friction. That's why the tension in all the cable will be same. So here it is tension T, here it is also tension T. If the friction is there, that means T1 by T2 is equal to e to the power of mu theta you have to consider. Okay, fine. So friction is not there. So you have to calculate the value of this particular mass M in the terms of T and G. So how you will solve this problem? So this is basically a bar whose mass is M. So what will be the force which acting downward? Body force is mg, and here is one tension T, and here is 2T, and here is another tension T. Okay, so these are the forces acting. Now you can use directly the summation of force in y direction 0. So three forces, that is nothing but T plus 2T plus T, which is T plus 2T plus T is equal to mg. So 4T is equal to mg. So can I write M is equal to 4T by G? Okay, and that you have to calculate. So the correct answer for this problem is M is equal to 4T by G, means option C. Option C. Option C. Okay, so I have covered the question based on the coplanar force system. In this particular case, only one equation is sufficient, that is summation of force in y direction 0. You have to use the three equilibrium equations, summation of force in x direction 0, summation of force in y direction 0, and take the moment about any point will be 0. So these three equations are sufficient for solving the problem of coplanar force system. I hope this series truly help you in your exam preparation. So don't forget to like, share, and subscribe. Thank you so much.